How big is big? How small is small? Right now, you're sitting somewhere on Earth, probably looking at a screen that's between 5 and 15 inches across. That feels normal. That feels human-sized. But what if I told you that compared to the largest known structure in the universe, our entire galaxy, all 100 billion stars in the Milky Way, is like a single grain of sand on a beach that stretches across multiple continents? And on the other end of the spectrum, what if I told you that the smallest particle we've discovered is so incomprehensibly tiny that if you scaled an atom up to the size of Earth, that particle would still be smaller than a human cell? Welcome to Universe Size Comparison 2026, the most comprehensive journey from the smallest known particles in existence to the largest structures in the observable universe. Over the next 30 minutes, we're going to travel across 62 orders of magnitude. That's a 1 with 62 zeros after it. That's a number so large, the human brain literally cannot comprehend it. But I'm going to try to help you understand it anyway. We're starting at the Planck length, the smallest measurement that has any meaning in physics, and we're going to zoom out continuously, exponentially, until we reach the cosmic web itself. Every object, every comparison, rendered in beautiful 3D so you can actually see the scale difference. By the end of this video, your perception of reality will be permanently altered. So take a breath, get comfortable, and prepare to feel very, very small, and somehow incredibly significant at the same time. Let's begin. We start our journey at the absolute limit of measurable reality. Planck length, 1.6 times 10 to the power of negative 35 meters. This is it, the smallest possible measurement in the universe. Anything smaller than this has no physical meaning according to our current understanding of physics. To give you perspective, if you enlarged a Planck length to the size of a single particle of light, that particle would become larger than the observable universe. That's how small we're starting. Now, let's zoom out slightly. Quantum foam, 10 to the power of negative 33 meters. At this scale, space itself is not smooth. It's bubbling, fluctuating, appearing and disappearing in what physicists call quantum foam. Reality at this level is not solid, it's probabilistic chaos. On your screen, imagine the fabric of space-time itself, rippling and warping at scales smaller than anything that could ever be directly observed. Strings. String theory. 10 to the power of negative 34 to 10 to the power of negative 33 meters. If string theory is correct, these are the fundamental building blocks of reality. Not particles, but tiny vibrating strings of energy. Different vibrations create different particles. Think of them like guitar strings, but instead of making sounds, they make electrons, quarks, and photons. Preons. 10 to the power of negative 24 meters. These are theoretical particles that might make up quarks, though we have no evidence they exist. We're including them because they represent the edge of theoretical physics. Quarks, 10 to the power of negative 18 meters. Now we're getting to particles we've actually detected. Quarks are the building blocks of protons and neutrons. They come in 6 flavors: up, down, charm, strange, top and bottom. You cannot isolate a quark. They only exist bound together with other quarks. If you try to separate them, you create new quarks. It's one of the strangest confirmed phenomena in physics. 10 to the power of negative 18 meters. Electrons are point particles as far as we can tell. They have no size at all, but their effective radius, the space they influence, is about this size. Every chemical reaction, Every color you see, every biological process, it all comes down to electrons moving between atoms, is less than 10 to the power of negative 24 meters. These ghost particles pass through normal matter as if it doesn't exist. Right now, billions of neutrinos are passing through your body every second. You'll never notice. They're so small and interact so weakly with matter that they can pass through a light year of lead without touching anything. Protons and neutrons. 10 to the power of negative 15 meters. 1 femtometer. These are made of 3 quarks bound together by the strong nuclear force, the most powerful force in nature. The nucleus of every atom in your body, everything solid you've ever touched, is held together at this scale. Now watch as we zoom out further. Atomic nucleus, 10 to the power of negative 14 to 10 to the power of negative 15 meters. The nucleus of a hydrogen atom contains just 1 proton. Uranium contains 92 protons and 146 neutrons, making it much larger. Here's something wild. The nucleus makes up 99.97% of an atom's mass, but only 0.000000000001% of its volume. An atom is almost entirely empty space. Whole atom, 10 to the power of negative 10 meters. If you scaled a hydrogen atom up to the size of a football stadium, the nucleus would be a marble in the center, and the electron would be a pinhead orbiting somewhere in the upper seats. Everything you see, touch, and interact with is made of these mostly empty spheres of probability. Small molecules, 10 to the power of negative 9 meters, 1 nanometer. A water molecule, H2O, 2 hydrogen atoms bonded to 1 oxygen. Simple, elegant, and absolutely essential for life as we know it. We're now entering a realm that's invisible to the naked eye, but absolutely teeming with activity. DNA, helix, width 2 nanometers. The double helix that contains your entire genetic code is just 2 nanometers wide. Uncoil all the DNA in one of your cells, and it would stretch about 2 meters. You have approximately 37 trillion cells. If you connected all your DNA end to end, it would stretch from Earth to the Sun and back over 100 times. Glucose molecule, 1 nanometer. The sugar molecule your cells use for energy. Every thought you're having right now is powered by glucose being metabolized in your neurons. 20 to 400 nanometers. Here we see a comparison of different viruses. Poliovirus, 30 nanometers. Influenza virus, 100 nanometers. COVID-19 virus, 120 nanometers. Smallpox virus, 300 nanometers. Viruses exist in this strange gray area between living and non-living. They cannot reproduce on their own. They need to hijack your cells. Proteins, 10 to 100 nanometers. Hemoglobin, the protein that carries oxygen in your blood, is about 64 nanometers. Proteins are molecular machines, each folded into a specific shape that determines its function. Smoke particle, 1 micrometer, 1,000 nanometer. We've now reached the micrometer scale. A human hair is about 75 micrometers wide, so these particles are still far too small to see. Bacteria, 1 to 10 micrometers. E. coli, 2 micrometers long. You have more bacterial cells in and on your body than you have human cells. You are essentially a walking ecosystem. Most bacteria are harmless or beneficial. Without gut bacteria, you couldn't digest food properly. Human red blood, 7 to 8 micrometers. These disc-shaped cells carry oxygen throughout your body. You have about 25 trillion of them, and your body produces 2 million new ones every second. They live for about 120 days, then are recycled. White blood cell, 12 to 17 micrometers. Your immune system's soldiers. Right now, they're patrolling your body, identifying and destroying threats. Human sperm cell, 60 micrometers. Half the genetic information needed to create a human being, equipped with a tail for swimming. Human egg cell, 100 micrometers, 0.1 millimeters. This is the largest cell in the human body, just barely visible to the naked eye under perfect conditions. It contains the other half of the genetic information needed to create a human. Grain of sand, 100 to 2,000 micrometers, 0.1 to 2 millimeters. We've now reached something you can actually see and touch. A beach contains billions of these grains, each one potentially containing quartz crystals millions of years old. Sesame seed, 3 to 4 millimeters. Small, but definitely visible, used for scaling cooking and, apparently, in universe comparison videos. Ant, 5 millimeters. An ant can carry 10 to 50 times its own body weight. If humans had the same strength to weight ratio, you could lift a car over your head. Honeybee, 15 millimeters. Responsible for pollinating about 1/3 of the food we eat. Without bees, human civilization would face catastrophic food shortages. Hummingbird, 513 centimeters. The bee hummingbird is the world's smallest bird at 5 centimeters. Its heart beats 1,200 times per minute, and it must eat half its body weight in nectar daily. 7 to 10 centimeters. Body length. A common research animal that shares about 97.5% of its working DNA with humans. Domestic cat, 46 centimeters average. Approximately 95 million cats are kept as pets worldwide. Each one is an obligate carnivore descended from desert wildcats. Human point, 7 meters, average height. Here you are, right in the middle of our journey. You are made of approximately 7 octillion atoms. 7 followed by 27 zeros. You contain entire universes of microscopic activity, bacteria, viruses, cells dividing and dying, proteins folding, DNA replicating. And you're about to discover you're vanishingly small compared to what's coming. Before we continue growing larger, take a moment to like this video and subscribe to the channel. Creating these 3D comparisons takes hundreds of hours of research, modeling, and rendering. If you're enjoying this journey from the quantum realm to the cosmic scale, your support means everything. Drop a comment and tell me which size comparison has surprised you the most so far. Now, let's keep scaling up. 5 to 6 meters height. The tallest land animal on Earth. Its neck alone is 2 meters long but contains the same number of bones as a human neck. 7. A school bus. 1-2 meters. A familiar reference point used in news reports to describe everything from whales to asteroids. Blue whale, 30 meters length. The largest animal ever known to exist on Earth, larger than any dinosaur. A blue whale's heart is the size of a small car and weighs about 400 pounds. Its blood vessels are so wide, a small child could swim through them. They can weigh up to 200 tons, being 747 70 meters. One of the most iconic aircraft ever made, capable of carrying over 400 passengers across continents. Statue of Liberty, 93 meters, including pedestal, a symbol of freedom gifted to America by France in 1886. From ground to torch tip, 93 meters of copper and steel. Big Ben Tower, 96 meters. Officially called Elizabeth Tower, this London landmark has kept time since 1859. Great Pyramid of Giza, 139 meters, original height. Built around 2560 BCE. It was the tallest human-made structure for over 3,800 years. It contains approximately 2.3 million stone blocks, each weighing 2 to 80 tons. 3 Eiffel Tower, 330 meters. When completed in 1889, it was the world's tallest structure. It remains an engineering marvel made of 18,000 metallic parts, held together by 2.5 million rivets. Empire State Building, 443 meters with antenna. Completed in 1931, this Art Deco skyscraper was the world's tallest building for nearly 40 years. 828 meters. Currently the world's tallest building, located in Dubai. From the ground to the top floor, 828 meters of concrete, steel, and glass defying gravity. If you dropped a penny from the top, it would take about 9 seconds to reach the ground. Mount Everest, 8,849 meters, the highest point above sea level on Earth. Over 6,000 people have reached the summit. More than 300 have died trying it. At the peak, oxygen levels are only 33% of what they are at sea level. Commercial airplane, cruising altitude, 10,000 to 12,000 meters. Most passenger jets fly at this altitude to avoid weather and optimize fuel efficiency. At this height, you're above 75% of Earth's atmosphere. Outer edge of troposphere, 20,000 meters. The troposphere is where all weather occurs. Above this is the stratosphere. Felix Baumgartner's jump, 39,045 meters. In 2012, he jumped from a helium balloon at this altitude, breaking the sound barrier in freefall. He fell for over 4 minutes before deploying his parachute. Edge of space, 100,000 meters, 100 kilometers. The internationally recognized boundary between Earth's atmosphere and outer space. At this altitude, the atmosphere becomes too thin to support aeronautical flight. International Space Station orbit, 408,000 meters, 408 kilometers. The ISS orbits Earth every 90 minutes at a speed of 28,000 kilometers per hour. Astronauts on board experience 16 sunrises and sunsets every 24 hours. GPS, satellite, orbit, 20,200,000 meters, 20,200 kilometers. The network of GPS satellites orbits at this altitude, allowing your phone to pinpoint your location anywhere on Earth. Geostationary satellite orbit, 35,786,000 meters, 35,786 kilometers. At this precise altitude, satellites orbit Earth at exactly the same rate Earth rotates, making them appear stationary in the sky. This is where most communication satellites live. We're now leaving Earth's immediate vicinity and entering the realm of moons, planets, and the solar system. The Moon, 3,474,000 meters. Diameter, 3,474 kilometers. Earth's only natural satellite and the fifth largest moon in the solar system. The same side always faces Earth because it's tidally locked. Distance from Earth, 384,400 kilometers on average. Earth-Moon distance, 384,400 kilometers. You could fit all the other planets in the solar system in the space between Earth and the Moon with room to spare. Mercury, 4,879 kilometers. The smallest planet in our solar system and closest to the Sun. A day on Mercury, sunrise to sunrise, lasts 176 Earth days. 6,779 kilometers. The Red Planet, home to the tallest volcano in the solar system, Olympus Mons, which is 21 kilometers high, nearly 3 times the height of Mount Everest. Venus, 12,104 kilometers. Earth's sister planet in size, but a hellscape in reality. Surface temperature, 462 degrees Celsius, hot enough to melt lead. Atmospheric pressure, 92 times that of Earth. It rains sulfuric acid. Earth, 12,742 kilometers. Home, the only known planet with life in the entire observable universe. 71% of the surface is water. The deepest point in the ocean, Mariana Trench, is 11 kilometers deep, 49,244 kilometers. The windiest planet in the solar system, with gusts reaching 2,100 kilometers per hour. It's so far from the Sun that it takes 165 Earth years to complete one orbit. Uranus, 50,724 kilometers diameter, the only planet that rotates on its side, likely due to an ancient collision. It has 27 known moons, mostly named after Shakespeare characters. 116,460 kilometers diameter, the ringed giant. Its rings are made of ice particles ranging from dust-sized to house-sized. Saturn is so light that it would float if you could find an ocean big enough. 139,820 kilometers diameter, the largest planet in our solar system. The Great Red Spot is a storm that has been raging for at least 400 years, larger than Earth itself. Jupiter has 95 known moons, including Ganymede, which is larger than Mercury. We've journeyed from subatomic particles to gas giants, and we're only halfway through. If this is blowing your mind, imagine what's coming next. Hit that subscribe button and turn on notifications so you don't miss our future comparisons. We're covering black holes, neutron stars, and the largest structures in the known universe. Comment below. If you could visit any celestial object we've mentioned, which would it be? Let's continue. Now we enter the realm of stars, massive nuclear furnaces that forge the elements necessary for life. Jupiter, again, for comparison, 139,820 kilometers. Jupiter is sometimes called a failed star. If it had been about 80 times more massive, it would have ignited nuclear fusion and become a star. Proxima Centauri, 200,000 kilometers diameter, the closest star to our solar system at 4.24 light years away. It's a red dwarf, small, cool, and it will burn for trillions of years. If you traveled at the speed of the fastest spacecraft we've ever built, Parker Solar Probe at 163 kilometers per second, it would still take about 8,000 years to reach it. The Sun, 1,391,000 kilometers diameter. Our star, a medium-sized, middle-aged yellow dwarf. 99.86% of all mass in our solar system is contained in the Sunday. It converts 600 million tons of hydrogen into helium every second. Every second, it releases more energy than all of humanity has used in our entire existence. Sirius A, 2,400,000 kilometers diameter, the brightest star in Earth's night sky, besides the Sun. It's actually a binary system, Sirius A and its companion, Sirius B, a white dwarf, 11,900,000 kilometers diameter, about 9 times larger than our Sunday. It's an orange giant that has exhausted the hydrogen in its core. Arcturus, 35,700,000 kilometers, a red giant star, about 37 light years away. It's one of the brightest stars visible from Earth. When our Sun runs out of hydrogen in about 5 billion years, it will expand into a red giant, similar to Arcturus, likely engulfing Mercury, Venus, and possibly Earth. Aldebaran, 61,400,000 kilometers, another red giant, about 44 times the diameter of the Sunday. If placed at the center of our solar system, its surface would reach about 61% of the way to Earth's orbit, 116 million kilometers diameters. A blue supergiant in the constellation Orion. It's about 40,000 times more luminous than our Sunday. Stars this massive burn through their fuel quickly and live only a few million years. 1,400,000,000 kilometers diameter varies. A red supergiant in Orion's shoulder. If you place Betelgeuse at the center of our solar system, its surface would extend beyond the orbit of Mars and possibly reach Jupiter. It's expected to explode as a supernova sometime in the next 100,000 years. When it does, it will be visible from Earth even during daytime for several weeks. 1,200,000,000 kilometers diameter. A red supergiant about 700 times larger than the Sunday. Its name means rival of Mars because of its reddish color. 1,975,000,000 kilometers diameter. One of the largest known stars. If placed at the center of our solar system, its surface would extend beyond Saturn's orbit. It's a hypergiant in its death throes, throwing off massive amounts of material. 2,376,000,000 kilometers. For years, this was considered the largest known star, about 1,700 times the diameter of the Sunday. If you were traveling at the speed of light, it would take you 7 hours to go around its circumference. Stephenson, 2 to 18 to 2,150,000,000 kilometers diameter, estimated. One of the largest known stars, though measurements are uncertain, located about 19,000 light years away in the constellation Scutum. Stars this large are extremely rare and unstable. Now, let's shift to the densest objects in the universe. 40 kilometers diameter. Wait, we're getting smaller again? Yes, but don't let the size fool you. A neutron star is what remains after a massive star explodes in a supernova. It contains about 1.4 to 2 times the mass of our entire sun compressed into a sphere the size of a city. A teaspoon of neutron star material would weigh about 6 billion tons on Earth. Its gravity is so strong that if you dropped an object from 1 meter above its surface, it would hit the ground at 7 million kmh, 20 kilometers diameter, a special type of neutron star with the strongest magnetic field in the universe. The magnetic field is so powerful that from 1,000 kilometers away, it would strip the iron from your blood. A magnetar eruption in our galaxy could partially strip Earth's ozone layer from 50,000 light-years away. Black hole event horizon varies by mass. Here's where things get strange. A black hole isn't really an object. It's a region of space-time where gravity is so strong that nothing, not even light, can escape. Stellar black hole, 30 kilometers, event horizon diameter for 10 solar masses. Formed when a massive star collapses, the mass of 10 plus suns compressed into a singularity. Sagittarius A, 44 million kilometers, event horizon diameter, asterisk. The supermassive black hole at the center of our Milky Way galaxy. Mass, 4 million solar masses. It's currently quiet, but it devours any star or gas cloud that gets too close. M87, black hole, 38 billion kilometers, event horizon diameter, 38 billion kilometers, asterisk. The first black hole ever photographed, 2019. Mass, 6.5 billion solar masses. The event horizon is so large that it would stretch from the Sun well beyond Neptune's orbit. Ton, 618 to 390 billion kilometers. Event horizon, 390 billion kilometers. One of the largest known black holes in the universe. Mass, 66 billion solar masses. This is difficult to conceptualize. It's 40 times the distance from the Sun to Neptune. If this black hole were placed at the center of our solar system, its event horizon would extend 1,300 times farther than Earth's orbit. We now zoom out to the largest structures in the known universe. The solar system, to 287 billion km diameter to edge of Oort cloud. Our cosmic neighborhood, containing the Sun, 8 planets, 5 dwarf planets, hundreds of moons, and trillions of comets and asteroids. The furthest spacecraft from Earth, Voyager 1, has traveled 23 billion km and is just now leaving the solar system after 46 years of travel. The Oort cloud, 1 to 2 light-years diameter, a theoretical shell of icy objects surrounding our solar system. This is the source of long-period comets. Light from the Sun takes over a year to reach the outer edge. 1 light-year, 9.46 trillion km, the distance light travels in 1 year. Light travels at 299,792 kilometers per second. In 1 year, that's 9.46 trillion kilometers. This is our new measuring unit for cosmic distances, because kilometers become meaningless. Distance to Proxima Centauri, 4.24 light-years, the closest star to us. Even traveling at light speed, it would take 4.24 years to reach it. Local bubble, 300 light-years diameter, a region of space with low interstellar matter, created by ancient supernova explosions. Our solar system exists within this bubble. Orion, arm, 10,000 light-years length. A minor spiral arm of the Milky Way galaxy where our solar system resides. The Milky Way galaxy, 105,700 light-years. Our home galaxy contains 100 to 400 billion stars. Our solar system is located about 26,000 light-years from the galactic center. The Milky Way is currently on a collision course with the Andromeda Galaxy, but they won't merge for another 4.5 billion years. Andromeda Galaxy M31, 220,000 light-years diameter, the closest large galaxy to the Milky Way, contains approximately 1 trillion stars. It's approaching us at 110 kilometers per second, but space is so vast that collision is billions of years away. Local group, 10 million light-years diameter, a collection of more than 54 galaxies, including the Milky Way, Andromeda, and the Triangulum Galaxy. Most are dwarf galaxies, gravitationally bound together. 110 million light-years diameter contains the local group and about 100 other galaxy groups and clusters. Our entire supercluster is being pulled towards something called the Great Attractor. Laniakea supercluster, 520 million light-years diameter, our home supercluster, containing 100,000 galaxies. Its name means immeasurable heaven in Hawaiian. Mass, 100 million billion sun. IC, 1,116 million light-years. The largest known galaxy contains about 100 trillion stars, 1,000 times more than the Milky Way, located 1.04 billion light-years away. Sloan Great Wall, 1.38 billion light-years length. A cosmic filament of galaxies, one of the largest structures in the universe. Discovered in 2003, it contains hundreds of thousands of galaxies. Hercules Corona, Borealis, Great Wall, 10 billion light-years, the largest known structure in the observable universe. It contains billions of galaxies arranged in a vast filament. This structure is so large that it challenges our understanding of cosmology. According to Einstein's cosmological principle, the universe should be relatively uniform at large scales. But this structure seems to contradict that. The observable universe, 93 billion light-years. This is it. The edge of everything we can possibly observe. The universe is 13.8 billion years old, but due to the expansion of space, the most distant objects we can see are now 46.5 billion light-years away in each direction. Contains an estimated 2 trillion galaxies. Each galaxy contains an average of 100 billion stars. That's 200 billion trillion stars. And we've only explored one tiny planet, orbiting one medium-sized star in one galaxy among trillion, the cosmic web. If you could zoom out beyond the observable universe, which you can't, you'd see galaxies arranged in a vast web-like structure. Matter isn't distributed randomly, it's organized into filaments and voids, creating a cosmic foam structure that resembles neural networks in the human brain. Multiverse. Theoretical. Some theories suggest our universe is just one of infinitely many universes, each with potentially different physical laws. This is speculation, but it represents the ultimate scale. Infinity. We've just traveled from the Planck length, the smallest possible measurement, to the edge of the observable universe. That's 62 orders of magnitude. If that didn't fundamentally change how you see reality, watch it again. Here's what I want you to take away from this. You are made of atoms forged in the hearts of dying stars. You are, quite literally, stardust that became conscious and is now contemplating the universe that created it. You're impossibly small compared to galaxies, but you're impossibly large compared to quarks. You're right in the middle, able to observe both extremes. Subscribe to this channel for more mind-bending comparisons. Like this video if you made it all the way through, you're in the 5% who did. And comment. What surprised you most? What do you want us to compare next? The universe is vast, mysterious, and more beautiful than any human can fully comprehend. But we can try. Thanks for journeying with me across the cosmos. Until next time, keep looking up.